Okay, good morning again, everyone. Today, well, this is actually 8.7. I skipped 8.7. I went from 8.6 to 8.8. And today we'll be looking at section 8.7, properties and transformation of square root functions. And I'll keep this pretty simple. We'll just take a look at the square root function. F of x is equal to the square root of x. When x is 0, I get y is 0. When x is 1, I get y is 1. The square root of 4 is 2, and the square root of 9 is 3. So when I graph it out, it graphs like that there. At 0, I have 0. At 1, I have 1. At 4, I have 2. At 9, I have 3. We always assume that underneath the radical we're working with the real number system, so we can't have negatives. We can't have negatives underneath the radical because I have an even index, okay? I'm taking the square root or index 2, so I can't have a negative underneath the radical. All right, so our domain then would be restricted to x has to be greater than or equal to 0. I can't have a negative x. That would be my domain, and my range then, as I take a look at that function, I see that the y values, the lowest the y values they get are 0, but then they increase without bound. Okay, so my range would be y is greater than or equal to 0. All right, so let's make some transformations. That's the parent function for the square root of x. Now we'll make transformations to that function here. So let's look at the next one. So again, this is my function, y is equal to the square root of x. And notice here that for this function here, I shifted the graph over 1, 2, 3 units to the left. So this function here, so my domain, so this function here would be y is equal to the square root of x plus 3. Okay, I shifted the graph over 3 units to the left. All right. When x is negative 3, I get negative 3 plus 3, I get 0. Okay. Again, so my domain here would be x is greater than or equal to negative 3. Can't have anything less than negative 3, otherwise I will get a negative underneath the radical. And again, recall transformations whenever, so if you recall transformations of like the quadratics, if I had x plus 3 squared, y is equal, so that was parabola, and remember to recall that shifted the graph. If this was y is equal to x squared, x plus 3 squared shifted the vertex over 3 units, 1, 2, 3. Okay. Again, the transformations, they work the same. Always counterintuitive, okay? X plus 3 means you shifted the graph over 3 units to the left. 3 units to the left. My domain is x is greater than or equal to negative 3. My range remains the same. Y is greater than or equal to 0. The y values, they never get below 0. All right. Just transformations. Let's take a look at the next one here. So again, this is my parent function, y is equal to the square root of x. Notice here, though, I shifted the graph over 2 units to the right. So this function is going to be y is equal to square root of, remember, it's counterintuitive, 2 units to the right, so it's going to be x minus 2. But then I also shifted the graph up. I shifted the graph up from the origin, 1, 2, 3. So I shifted it up 3 units. So it'll be y is equal to the square root of x minus 2 plus 3. I shifted the graph up 3 units. My domain, now it has to be x is greater than or equal to 2. I can't have an x that's less than 2, otherwise I'll get a negative underneath the radical. And then my range will be y is greater than or equal to 3, because the y values, the lowest the y values get are 3. Okay. And then it goes on forever. Let's look at, so here again, I have my parent function y is equal to the square root of x. Notice here that I reflected the graph across the x-axis. To recall, whenever we do that, we multiply the entire equation by a negative. So this would be y is equal to the negative square root of x. Okay. When x was 4, I got y as 2. Now when x is 4, I'll get y is equal to negative 2. I just shifted the graph across the x-axis. Remember, when you multiply by negative, you reflect the graph across the x-axis. Let's look at some more transformations. So again, here's my parent function, y is equal to the square root of x. So let's see here. So from the origin, I went 1, 2, 3, 4 units to the left. So my function is going to be y is equal to the square root of x. Remember, counterintuitive, plus 4. I reflected the graph across the x-axis. So notice here, I reflected across the x-axis, so I need a negative. And then, when I take a look at from the origin, I shifted the graph down 1, 2. I shifted the graph down 2 units. So this function is going to be y is equal to negative the square root of x plus 4 minus 2. So my domain for this function will be, again, x has to be greater than or equal to negative 4. Can't have negative 5. Negative 5 plus 4 would give me negative 1. You can't have a negative underneath the radical. And then my range here. So notice that the lowest the y value gets is at negative 2. It's that value there. But now it's going to be y is less than or equal to negative 2. Y is less than or equal to negative 2. The y values never go any higher than negative 2. Okay, let's see here. Yep. And, you know, it's plus 3, so it's going to be y is greater than or equal to 3. And, yeah, and maybe, let's see here, do I have another one here? Oh, what happened to my graph? I deleted by mistake. I guess I did. And then the last one here, if I have any more. Well, I guess that was it. So transformations, we've done this a gazillion times, so these should be pretty easy to be able to identify the domain and range given the function.